So welcome to all. This is our first North American NORR Ed, our virtual NORR Ed for the group. And welcome to the Toronto, the Ottawa, the Calgary, the Edmonton offices, as well as the Detroit, the Chicago, Philadelphia, and Sacramento offices. I want to do a special welcome to the staff that are furloughed, and as you all know, that as soon as we can, we're going to have those furloughed staff back into the offices. All of you are working from home, and as Brian Gersmar, our CEO, said just recently, we're still not sure when we're going to reopen the offices, but things are working well, and everyone is busy in their home offices, and we're going to continue to do that for some time. For the architects that are online in Ontario, remember the learning objectives to fill out your forms for the learning objectives for the NORR Ed, and remember to submit them to Patricia Clark to receive your credits for this session. The NORR Ed that we have today is our fifth one that we're having this year, and it's Mike Picco. The next one will be the Renzo Piano Santander movie that we'll be showing on October the 20th, and that will be supplemented by the designer and the project manager from the Renzo Piano Paris office after the movie. And then in November, we'll have Lloyd Keller, who will be talking to us about architectural concrete. And then in December, Stefano Pugliatti will be talking to us about his work. We're not quite sure if Stefano is actually going to be in Toronto. Most likely he'll be doing it from Milan virtually, and he'll be talking to us about his work going west. So as most of you know, today's talk is about stone cladding and getting it right. So stone cladding, natural stone, the material that comes out of the ground, formed by natural environment over the ages. Used since the beginning of time as building material, it remains one of the most aesthetically beautiful natural materials, durable, easy to maintain, recyclable, quarried and manufactured sustainably, and used for its inherent strength to last over the ages. For architects, we struggle with the industry to understand what we should and should not use. There's so much misinformation caused by sales information directed by cost, test information that is confusing, the want to use material because it looks good, but may not be the most appropriate for the application. How do we as architects detail the engineered connections? Are we qualified? And if not, who is? And how do we control the selection and detailing when we have the final responsibility when everything goes wrong? Not the contractor, not the sales rep, not the supplier, not the quarry. The three guests today are the architect's best friends. They're the experts, and working with them, they'll keep us out of trouble. Our presenter today is Mike Picco, an engineer and stone specialist. I met Mike at the Stone Conference in Siena, Italy, over 10 years ago at his lecture on stone. He impressed me with his detailed analysis of material that is difficult to quantify without really understanding it. Mike will be joined by a quarry owner in Carrera, Italy, Roberto Canali, where it's about 10 o'clock, I believe, in Italy. And Roberto, thank you for staying up late for us today. And Brent Ruggio, a specialist contractor fabricator from Virginia in the US. who will also be joining with the discussions during this presentation. And with that, what I'd like to do is turn it over to Mike Picco for his presentation today.
Thank you, Silvio, and thank you all for joining us today. Just to give you a brief overview, we will be covering a lot of things. I'm going to be bouncing around. I want to feed you with as much information as I can today. So if there are any questions, we'll hopefully leave some time at the end to answer any of your questions. We're very fortunate to have Brett and Roberto with us today. So just, to speak a little bit more about what Silvio mentioned here, I mean, we're talking about the oldest building material in the world. I mean, as far as sustainability, I don't think there's other material that can stand up to it, and we've got structures all around the world to reflect that. With the advent of technology now and CNC and robotics, architects can get a lot more creative with the use of stone as a facade, where it's now, rather than just a building material, it becomes just a decoration on the facade and the main line of defense for weather in a mostly rain screen principles now. And again, with the advent of technology, this is a sample project, the Museum of Natural History in New York, where we got involved with the architects early on with a presentation and looking at costing. These were their initial concepts. They felt doing it flat and faceted would be the cheapest way to do it, when in fact, when we priced it out in larger pieces with CNC equipment curving the stone, they actually achieved what they were looking for at least as good as, if not cheaper price, because of the new technology now. So just the way things have changed over time and evolved, and later on we can even get into some of the technology changes with Roberto and Brett and how that's really changed the industry with time. So today, as I mentioned, Brett Rugo is the founder of Rugo Stone, and we've worked on many projects with them. Roberto Canali is a quarry owner and fabricator in Italy, and again, we've crossed paths on many projects over the years, so I'm really glad that they were able to join us today. A little bit about me. I've been in the stone industry pretty much all my life. I graduated as an engineer, and my first job was with a structural engineer, but we were servicing stone contractors. I then got hired by one of the stone contractors as their in-house engineer, and since then have been engaged and love the industry and have touched many points of it, and feel very fortunate to have worked on some great projects, which I'll share with you today. Being born and raised in Toronto, I still play hockey, so that's a big part of my life too. And my couple of times a week, I put the skates on and go out with the boys and play hockey. So today, we're going to talk a little bit about design assist and the importance of that, especially on higher profile projects. Cladding types. I'm going to cover topics that I call getting it right the first time, which covers various aspects and approaches. Other things to consider, testing and projects. And throughout the whole projects, I'm going to be weaving in project examples to kind of talk about the various aspects. So right out of the gate, I think design assist is something that's becoming a lot more prominent. Jobs are getting more complex, technology's changing, things are changing in the industry. And, for architects to try and keep up with all of that becomes a real challenge. So we've actually been involved in a few design assist tenders where that's the first part of the job, is really to vet out the most appropriate way to approach a project. So, a traditional material supply chain would look something like this, where, you start with the quarry. Quarry may supply to a block trader or an operator or a broker. Broker then would be dealing with somebody potentially overseas, depending on where the stone's coming from. It moves somewhere, gets to a local supplier, gets tendered, specified on a job, gets to the local contractor, fabricator, and eventually gets to the job site. And throughout that process, there could be a lot of question marks on breakdown. Is it the right material? Are we dealing with the right material? Is it available at the sizes? So many different factors that could come into play. What's becoming a little more common, especially on, again, higher profile jobs, is assembling a team right at the beginning of the job and streamlining that process. So the quarry fabricator works with the design assist team, working directly with the architects, owner, stakeholders, and really directing the best solutions for the project with no vested interest on any of the aspects. We're really driving what's the end goal of the project and what's the best way to get there. And this really is becoming more of a common trend where this becomes part of the prime consulting team when you're working with a high profile stone project. What are some of the things that comprise of the design assist? You know, preliminary quarry visits, understanding the material, what ledges is the stone coming from, how does it vary? When you're looking at a 6x6 sample or a 12x12 sample supplied by a material supplier locally, you don't understand all those things. So meeting the quarry owner, understanding limitations, understanding best things, working out best slab sizes based on the blocks being quarried, different methods of fabrication that could obviously affect the project, installation consulting, being able to provide information to the structural team on best practices or best attachment points. You know, do we build a subframe? Do we not build a subframe? Do we go back to structure? All these things could be vetted out very early and becomes part of really the design development of the project itself. So not only are we looking at obviously the architect's intent and trying to keep the integrity of the project, but also assisting with the structural engineers on maybe the best approach for backup. We're involved with a couple of projects right now where, you know, the best approach is to sit the bearing points at each slab edge. Well, the structural engineers have gone too far beyond that, where they said, well, we didn't design the slab edge to carry the loads there. Although that is the best approach, we're having now to look at various options or go through a structural redesign. So these are really cost-effective ways of vetting all that stuff early with a little bit of upfront consulting and planning. It could involve inspections during the fabrication, dry lays, vetting the tickets, fabrication. It could also include shipping, logistics, numbering of stones, making sure the stone is shipped to the site in the sequence that it's required. We have been on projects where, you know, we're told, oh, there's, you know, the stone's on site. Yeah, the stone's on site, but it might be all the second floor stone. You don't have the first floor stone. So you can't, again, understanding all the logistics. And, you know, when you're assembling a team early on, you know, contractors like Brett that have been in it all their life, you know, quarry owners like Roberto. I mean, these are all things that automatically come out in the process, but you're not always working with experienced people like that. And some of these things get slipped through. So really assembling a good team at the beginning is extremely important. What's becoming really popular now is dry lays and digital dry lays, where quarries and fabricators are photo documenting all the slabs that are being produced. And here's an example here. You can actually lay out the materials on your elevations and do a digital dry lay. So this would be photographed, develop the elevations on the drawings, cut the pieces, dry lay them, ensure everything's right in the warehouse before shipping and packaging, numbering all the stones appropriately, and shipping out. This is a project actually that Roberto and Brett both collaborated on. It's an award-winning project that was submitted for a Pinnacle Award and won Pinnacle Award of Excellence, I believe it was last year. Here's another elevation where the actual pieces are digitally shown on the elevation with the jointing patterns laid out. Here's a bit of a blow up. Here is the dry lay in the shop in Italy, making sure everything fits properly. And here's some photos of the lobby at the end of the installation. So you can see how all that planning, organizing, selecting blocks, selecting the slabs, numbering the slabs sequentially, and all that planning, in order to achieve this goal, that needs to be all done up front. And really all the stakeholders need to be part of that process in order to pull it off and execute it properly. So when I look at stone and the initial stages of a job and really assisting architects in the takeoff, I like to break it up into two categories when we're talking about natural stone. Dimension cut stone, which is really the focus of the presentation today, is custom cut stone shaped, fabricated specifically to go in a location, which requires shop drawings, engineering, shop tickets, most often installed mechanically with anchors. So in other words, we're building a Lego set of drawings, every piece numbered, every piece goes in its specific location. So some examples of jobs like that would be projects like this. So could be high scale residential, commercial, institutional, university buildings. So every one of those stones has a number. It's got an engineered anchoring detail that connects back to the structure, and every piece has its location on the building. Another natural stone type is random ashlar, which is still a natural building material, still used a lot. Typically doesn't require shop drawings. In some cases may require shop drawings for accent stones, window surrounds, but in most of these cases it's laid up very similar to a masonry type installation or brick laid up in mortar. Very often the anchors are relying on the mortar adhesion to tie back to the building. Sometimes will require some mechanical anchors, and some examples of that are natural stone projects like this. Again, both natural stone. Our focus will be on the previous one, which is the dimensional cut stone instead of the random ashlar. Key factors to getting it right the first time. So 5 main things. Material selection obviously is number 1. Structural backup can have a huge impact. Shop drawings, anchor design and anchors. I'm going to go through each one of these individually. So material selection. First thing, is the material selected suitable for the intended application? Obviously climate plays a big impact. Where is the project? Is it exposed to the elements? What kind of wind loads? Are we dealing with seismic loads? All these factors come into play. Stone is a natural material. It's not like we can order 35 MPa concrete and we get 35 MPa concrete all the time and we know what we're dealing with. Natural stone is a very variable material. The same natural stone can even vary within a quarry depending on what ledges it's taken from, especially limestones can vary quite a bit in strength. So really, is the material that we're specifying the right material for the application? I always tell architects there's no bad stone as long as it's used in the right location. There's stones that can be used improperly in exterior cladding or on paving that could have terrible results. But if they're used on an interior or a lobby on an interior facade, perfectly fine. So material selection and suitability, very, very important. The other thing is the material quarried available in the specified size that you'd like to use on the project? On the left, you can see a quarry. This is a slate material. Actually, I think it's a basaltina, maybe. I'm not quite sure. I can't remember exactly. But you can see on the right side, one of the Euro marble quarries here, you can extract very large blocks, and I've got some other examples of that. Here's some other examples of the top left is a limestone, and limestone comes out typically in natural bed heights. So the blocks come out depending on where the soft bed lines are. So availability of large panels in some of those materials is very limited. So when you're specifying large panels, it could drive the price up because the yield is not as high. The bottom left corner, again, large boulders that get squared off and cut to size. those, again, if you're specifying a large panel size, you're going to drive costs way up. So really, these are some of the benefits of visiting the quarry or speaking to the quarry owners and really understanding your material at the onset of the project, really to drive a lot of your decisions. If the panel size is extremely important, you might have to change your initial material selection to go to something else. If the material that you're dealing with is the important aspect, then maybe panel size changes and your jointing patterns change. So there's various ways to deal with it, depending on what the importance of the job is. I'd like to show you a few little slides here that show you some of the quarrying methods. And this is a video of a large block being extracted at the Botticino quarry in Italy. And I'll just run a short video here of it. So that's one method where they make certain cuts and then they blast it off the wall. So that's one example. And in most cases, they allow the blocks to fall off the bed, ledge, or drop down. Several reasons for doing that. If there's any natural fissures in the stone, they're gonna show up when the main blocks get dropped very often. So again, various methods. I'll show you on the next slide. This is an excerpt from about a 7-minute movie that was done on some of the block quarrying in the Carrera area, where Euromargle's quarry is. And this, I've just taken a small excerpt of this, and this is really cool as well. It's called Il Capo, which is the boss, and he's the guy really controlling how the blocks get dropped off the side of the mountain. I thought I'd share that. It's pretty cool. It's almost like a conductor directing his orchestra. Pretty cool to see that. And the goal right now, and I'll let Roberto speak to that later, is they're trying to drop as large a block down off the main ledge, and then they do all the cutting while it's down on the ground. And obviously the limitation is how much weight can they put on the truck to get it down, so they have to cut them down to the sizes that are manageable for transportation. Still on the theme of material selection, is it suitable at the specified thickness? Again, we do testing depending on the strength of the materials. If the desire is a material and a certain material to be used on a project, I mean, typically when we're dealing with claddings, 3 centimeter, 4 centimeter, 5 centimeter is kind of the range that we're dealing with. So anywhere from, 1 1/8 to 2 inches thick, but thickness can vary depending on the need of the project. And that's another thing that getting involved with early, we can optimize what is the best thickness and the best panel size for a certain project. The other reason for getting involved with the appropriate stakeholders, depending on the project, you know, are they capable of producing to the quality required? Can they deliver at the quantity required? On larger projects, sometimes quantity and delivery is important. You know, technology and availability of technology varies greatly depending on who you're dealing with and what parts of the world you're dealing with. So understanding that is also very important. Again, a big part of the QC control of the project. Testing, current test material. We get very often historic test material sent to us. And as I said, as the material gets quarried in the mountain, I mean, there are some materials that are very, very consistent, others are not. So really having current test material is very important for cladding projects or projects of some importance. I mean, if we're dealing with a wainscoting in a lobby, not important. But if we're dealing with soffits at a main entrance of a building and cladding on commercial institutional buildings becomes very important. The level of testing, again, is really predicated on the nature of the project, and testing can be very, very simple, or it can get very, very complex. And I'll even show you some large scale mock-up testing a little bit later on. But, you know, testing the anchors, testing panel strength, what we call that is an airbag test, where we actually simulate wind loads or seismic loads, lateral loads on the panel by having an airbag anchoring the stone into it and actually testing it to failure. So we understand where the failure mechanisms are within the assembly, whether it's the anchors or the panel itself failing. Structural backup, again, having some say in that and working with the structural consultants can really have a huge impact on cost and ease of installation. So, I mean, obviously a concrete or masonry backup wall is preferred because we have unlimited places to locate your anchors, but it may not be the most efficient from a thermal perspective. So aluminum subframes or subframes become an option sometimes. Metal studs we're dealing with a lot because it's a cheap building material. But when we're mechanically anchoring stones to metal studs, there's a lot of other complexities that could come into play. If they're addressed early on, again, we can integrate a lot of that into the structure to facilitate some of the anchoring requirements later. When we're dealing with random ashlar, again, not as much of an impact because it's laid up similar to a brick. So as long as you've got bearing or shelf angles, the tieback is usually by mortar adhesion. So a lot less of an impact. Shop drawings become a big part of the process. Understanding, you know, clear shop drawings will obviously give the architects and designer a clear understanding of exactly what's happening with the job. Shop drawings should include all the interface of all the adjacent materials and how the stone's going to interact with adjacent curtain wall or flashings or whatever. So that can all be vetted out early. Make sure there's no conflict with connections or anchor details that may impact flashing or details that may conflict with other trades. So the shop drawings really should be an integrated process of all the associated trades really interacting with each other and making sure that, you know, sequence of installation is also addressed. Who needs to go first? Is the curtain wall going to limit our access to a connection that's critical? So do I need to go in before the curtain wall contractor, or do I need to modify the anchors to facilitate the curtain wall contractor? So sequence of who goes first becomes very critical very often as well. So I'll show you a few. We were fortunate to work on the Barnes Foundation building in Philadelphia, and this was a concrete structure, and the architect designed these panels with windows integrated in and some slots with reveals. Some of them were windows, some of them had backlighting. So we looked at several different options here to approach this. We looked at potentially pre-panelizing it, creating panels offsite and coming in and almost installing this like a precast installation. But working with the installation contractor, they preferred to do site installation and hand set the stone. So it was a rather large project, and what we did is, broke it down into a bunch of little sections. Here's an excerpt from zone 25, which is this part of the building here. So you can see that it's a somewhat of a random panel sizes. Again, the panel sizes were driven by the block size availability. So in order to minimize the waste of the material being quarried, the architects worked very closely with the material supplier in order to develop a jointing pattern where we used almost all the material with very little waste. So again, you can see how heights and widths have varied in the different panels in order to create this random pattern to utilize the block sizes available. And what we did was we created an elevation here with all the stone mark numbers. Every stone had a unique mark number by zone and panel location. So there are just different prefixes in order to track all the various stones. And then we overlaid behind it the anchoring connections. So the installer had kind of two drawings, one for the structural backup, the next one to install the stone on the front. And we came up with a very simple anchoring solution, which consisted of two HSS tubes connected top and bottom to the structure, and then all our connections came off that. We developed an anchoring system that came all outside the insulation. So all the tubes were exterior of the insulation in order to keep the integrity of that, minimize the amount of thermal penetrations through the insulation. So that's why we designed the tube with only two penetrations, top and bottom, through the insulation. So here we can see very simple, easy to fabricate solution. You can see how the tubes are offset to allow for the insulation to run in behind them, and then the stone was proud of that. And when we talk about shop drawings, depending on who the stakeholder is that's doing the shop drawings or contracted to do the shop drawings, if a material supplier is supplying the material and is not contracted or is not responsible for the installation, that's coming downstream, you very often, or we often get drawings like this in order to do our engineering with. So really, you look at this detail at the top here, and the stone is all detailed properly, it's all dimensioned, everything's clear on the stone fabrication, but we have nothing on the structure behind. So in order for us to do the engineering in a set of drawings like this, we basically have to go in now and extract from the structural drawings and architectural, what is the structure behind here to anchor to. So when specifying your requirements in the shop drawing requirements, make sure that all the structural elements associated with the stone anchoring and the adjacent building materials is part of that specification, part of the requirements of the shop drawings. It just makes everybody's life so much easier downstream if that's addressed early on in the process and becomes part of the shop drawing development process. Anchor design with dimension cut stone. There are some proprietary rail systems out there, some standard, what they call standard connections out there. But in essence, every job is custom designed. We have stones with different properties. We have different climate conditions, whether it's wind, seismic, thermal, freeze-thaw environments, non-freeze-thaw environments. We have different cavity sizes to deal with. We have different structure to tie back to. So really to try and standardize anchors becomes almost impossible. So for the most part, anchors are custom designed. They may be variations of very similar anchors, but they're all engineered for each specific project. With some of the larger stones that are stacked or stones that are set in mortar adhesion, a little less critical. But on custom cut stones, all the anchors are engineered, and that should also be in the specification that they should be engineered, detailed by an experienced cladding engineer in wherever your project is. Again, as I mentioned, in random ashlar, very often off-the-shelf type, almost brick tie type anchors are very often suitable in those, although sometimes we will still design some strap anchors with some mechanical engagement into the stone as well. So going back to the Barnes job, here are some of the actual connections that we use off that tube structure. So you had these tubes anchored back to the structure, insulation ran behind it, and then we had connections off these tubes. Here you can see kind of a typical split, what we call a split tail connection with a kerf or a saw cut in the stone that basically bears the stone on it and also ties it back to the structure. This is a very typical type of anchoring solution. This we call a blind connection. Installers don't like it, and Brett could speak to that a little bit later when we're dealing with blind connections. This one here allows you to have the stone in place, set the anchor, and if you require some adjustment, it's accessible. In this case here, because the bottom of the stone is exposed and you can actually see it, we obviously can't put an anchor in there. We have to anchor from the back of the stone, which makes it a little more difficult because this anchor has to be set exactly in the location in order to receive the stone properly. Some of the other anchors, again, special anchors. This is a soffit condition where we actually epoxy a rod in, anchored into another connection, coping stones coming off masonry walls. So you look at the elevation very often, and everything looks very typical, rectangular pieces, and then when you get to the backup and how it needs to get anchored, it's nothing but typical. You get into the shop tickets now, so these would be, fabrication sheets that Roberto or Brett would be working with in their shop, which would require all the information to prep that stone for the install on the job site. Dimensions, any finished edges, any slots or holes or dowels to anchor the stone back to the to receive the anchors is all shown in here. And here are some of the details that are required for saw cuts, pocket slots here. Again, kerfs with rabbets because it was a tight joint, so we need to rebate the stone in order to receive the anchor and still allow for a tight joint or a small joint there. These are, we call T31s or T-bolts, which are slots like this that a rod with a little tapered metal plate goes in order to anchor stones. So again, kind of various standard trade details that fabricators would be very familiar with. Same way we do shop tickets for the stone, all the anchor details get detailed, they get numbered, they get tagged on all the details, and they all have their specific location on the building. Because cavity spaces vary, stone sizes vary, these plates may vary depending on where they go on the building. And then, in order to facilitate ordering of all the plates, a quantity takeoff and a listing of all the hardware plates required for the job is usually developed, and the installer is usually responsible for that. And very often they won't order all the hardware unless they have the availability to do a site survey before, because site conditions sometimes require that certain anchors be ordered longer or shorter, because we all know that the structure is never really where it's shown on the drawing. Although we as an industry have been trying to push hard on some of the trades out there and even specifications to tighten up on the tolerances on the building structure itself, because some of the things we're seeing out there now where, a 4-inch cavity or a 5-inch cavity could be anywhere from 7 inches to 3 inches. And the tolerance in structure seems to be going awry, and it's left to people like Brett to deal with it on the job site. And, additional costs, additional surveys, additional delays, ordering custom hardware, all because the structure is not really adhering to their code limitations on tolerances. And it seems to be more and more accepted that they can do that, but the stone has to be set where it needs to be set. So as an industry, we're trying to push hard a little bit back on that, not with a lot of success, but it's something that we're finding more and more challenging because we can only build in so much tolerance in the initial design. So something we're working on. I just want to now give you a few different examples just to change gears a little bit, some project samples of different things. So this is a large scale residence that we did in Toronto, and a suburb of Toronto. And I want to show this because we actually use stone as structure here. Those 4 columns are actually supporting the steel gable at the top. There's no tubes or steel going down to the foundation. And we very often have to fight with the building departments because they're not familiar with that. They're not comfortable with that. So we often have to fight to get through it. And, we take responsibility, we design it, and we very often show them examples of, 500-year-old buildings in Europe with columns supporting very large structures above, and there's no steel in them. So we usually design connections with slots, Teflon plates, or similar to bridge connections that allow some movement between the structure and the column, so we don't induce lateral loads on the columns, but basically support vertical loads. So there needs to be some design in the approach. So the roof structure would be designed as a diaphragm tied back to the structure, and then allows for some movement between the steel structure and the stone. And we've done that on quite a few projects successfully now. We're actually at Belmont University right now doing a similar application where all of the main columns on all the gables are all structural, and we're bearing the steel structure on the stone columns. Here's another project that from the exterior looks like a very common flat material, flat soffits. Again, with the advent of technology, the cladding on the facade is all 2 inches. The cladding on all the soffits is 1/4 inch on a honeycomb backing. So the stone's all cut to 1/4 inch, honeycomb reinforcing, very, very light panels that get fastened up with the rail system onto the soffits. But to the finished product, you can't tell if that's 2 inch thick or 1/4 inch thick once the joints are sealed. Very seamless installation, helps with the structural loads because of these large cantilevers. We wanted to minimize the load of the soffits. So again, getting involved early and being able to influence some of that design really aids in the installation. Again, with the advent of technology, these projects here used to take a lot of time and effort, hand carving, a lot of handwork. Now the handwork has been minimized a lot on these ramp and twist stairs to, robotics and technology and CNC equipment brings that down very close to the finish. They usually still require some handwork, but costs and schedules have been brought down because of the advent of the newer technologies and some of these more complex projects. So we're seeing them used more. I think one, because costs have come down and scheduled deliveries have been compressed, which we all know schedules are getting ridiculous now and trying to meet schedules. So technology has helped in a lot of those cases. Here's another project where in the Museum of Modern Fine Arts in Montreal, we worked with the architects. We visited the quarry. This is the Danby Quarry in Vermont. They picked the blocks off the quarry wall. We numbered the slabs and tried to mimic the quarry face in a repeating pattern up the job. And you can see the entrance was really executed very nicely there, how the veining wraps right around and down the soffits. So that was a fun project to work on. Again, just another unique project to share with you. This was at the Academia during the fair, the Milan Expo, and it's an exact replica of the statue of David as far as size and scale goes. And again, CNC equipment, every single stone is carved, and we actually pre-assembled that in the shop in 5 different sections, because that was installed in one night. They had one night to install that. So it was craned in from the exterior into one of the courtyards at the Accademia in Florence and installed in one night. So again, that was a fun project to work on, and it was made from the same Carrera material as the actual Statue of David, quarried in the same area. Foster and Partners, this is the Apple headquarters in Cupertino. Again, CNC equipment, very active in the process. Apple and Foster, very, very particular. Every single radius on that stair and railing and everything is a direct proportion of the radius on the iPhone and the iPad and the everything. So they were really, really particular on the detailing and the modeling. They actually, when we gave them our finished model of all the pieces, they actually put a chrome finish on it to see if there were any imperfections on any of the radii or any of the modeling that was done. Although a lot of it was finished by hand at the end, they did a great job on executing that. This is another one I want to share with you, just where technology is going with stone now. This is a private residence in Toronto, where the architect had originally designed a cantilevered stair off the wall, and they came to us because they had challenges. It was a historic home. They couldn't touch the wall, the exterior wall, because it was a historic home, and they didn't want to disrupt any of the stone material on the exterior, which would have required a pretty large structure and ate away a lot of space in the wall in order to create a cantilevered stair off the structure. So we said, why don't we just build a structural stone stair? We don't need a cantilever. We'll pull it off the wall and we'll design a self-supporting stair to span top to bottom. So we developed some details on this. We ran 3 post-tension cables up the stair. And so we built a temporary support. Everything was shimmed off the temporary support for installation. At the end, post-tensioned all the stairs. We took all the shims out of the structure and we load tested it to 2 times the design load, measured deflections at 3 points on the stair, and we had 1.5 millimeter of deflection after we loaded it with all those masonry steps. And here's a section of the stair, and you can kind of see here we've nested each little stone into each other, which is kind of hogged out in the middle, which you don't see anywhere, but that created a perpendicular line that we could run the cables right through. So again, fabrication became really critical because these holes had to all align in order for the cables to run top to bottom. So there's a section of our stair, and there is the completed installation of that stair. No steel, no structure, nothing but stone, and 3 embedded post-tension cables is all that's used to support that stair. And we're looking at a lot of different projects that are going to utilize this technology now, even curved traditional type stairs with running cables through them. So rather than building a big structure and trying to clad everything later, we're building solid cubic stairs and using them as the structure, running post-tension cables through it, and none of the steel is exposed. So just sharing some of the, again, newer technologies that we're exploring. Here's a more traditional type of stone installation. A lot of stone on the project, but integrated with brick. A lot of this was installed very similar to brick installation with tiebacks, but we did get into areas. Again, here's, again, with the scale of the job, large scale mock-ups in order to understand the integration with all the various building materials, how they tie into each other. Some of the structural elements around bay windows, we were able to vet out and come up with the best solutions for installation and sequence. So again, depending on the nature the project. I mean, site mock-ups, whether they're off-site, independent mock-ups, or even mock-ups part of the finished product, is always a good way to start a project out. Even if it's just for checking, mortar colors or caulking colors, the installation type, sequence, all that. Always a good idea to have a mock-up. Being involved with this job early allowed us to, again, influence a lot of the structure. So we were integral with the design team at Stern's office, with Silman's office, which were the structural engineers, and driving a lot of what they needed to provide us in order to support the stone, or in order to facilitate the easiest stone installation. The other things we're allowed to do is we're influencing how the stones get fabricated. These were initially designed as much lighter angled stones on the back, but the installation became a lot more complex to try and get that in with the angled backs. So we said, let's fabricate the stone square, create a square structure behind here and steel framing that allowed us to install the stone much easier. So sometimes it's better to pay for a little more stone to save down the road to make the installation way easier later. Here's another example here where the original structure had steel columns on each side of this doorway, a steel beam running across, and everything clad in stone. And we said, why don't we just build a stone arch? Get rid of all the steel, let us build a stone arch. It's way simpler. It makes the installation easier. Yes, there's more stone involved, but a net was a huge cost saving on the project. So we got rid of all the steel, designed a structural arch, picked up all the stone above there on a true stone arch, and then we started with shelf angles from the second floor up and started burying the stone above there. Again, being able to drive some of these decisions early on is really beneficial. When we talk about anchors, we're always specifying 300 series anchors. So anything in contact with stone, we like to use stainless steel in order to minimize any potential for corrosion, rusting, staining. We can integrate galvanized steel as backup anchors. So when we're designing framing or anything behind the stone, the only thing is when we're transitioning from stainless to galvanized, we need to separate with a dielectric separator because they're incompatible materials, especially in moist environments. So it becomes not a complexity, but something that needs to be ensured that's followed on the job site. So very often, if possible, we like to drive an all stainless solution, so it eliminates the need for dielectric separation. So, dumbing it down to very, very simple, typical type of anchor details. This is a typical what we call two-piece pin connection, an angle, a plate, a bolt, slotted connection allows for in and out, vertical slot allows for up and down, so it gives the installer some adjustability. Typically insulation is run through there, so there's a pocket cut out in the insulation, the angle gets installed, the insulation gets either fit back in or foamed in and taped depending on the type of insulation, but you're creating a small thermal bridge going through there. Depending on the nature of the project, lead requirements and thermal requirements, you could have a thermal break behind the angle that creates a little bit of a break on that thermal bridge. Sometimes the plates are separated to break the thermal bridge. So there, again, various ways to deal with thermal bridging depending on the installation type. Here's what we call another blind type connection, which is a blind anchor again, which we try and avoid as much as possible because the installers don't like them and they become a little trickier to deal with. There's a lot of proprietary rail systems now that are becoming a lot more prominent. So the vertical and horizontal rails become your adjustability, and then the anchors go in and set in place. This is kind of showing how the back anchor is set in there. This is a very thin actually glass panel but similar type of systems could be used for stone as well. And when you look at the back, you've kind of got these verticals to the structure, horizontals depending on your jointing patterns, and then the panels come in with these clips and just clip into the rail systems. And again, there's a number of these on the market right now. Here's one that actually Brett and I are working on with a project in Washington, D.C. right now with a very similar installation to this one, where it's almost like a curtain wall. So we're spanning main structure floor to floor with these vertical aluminum sections. Insulation is integrated right into the panel system, and then all the anchors are proud of that. So it's a fully integrated wall system that encompasses air, vapor, insulation, and the panels themselves. So fully integrated system. It's going quite well. Brett's in the middle of that project right now. Maybe we can speak a little bit about that after as well. One-piece connections. These are very often sometimes used in lobbies, in interior applications, light applications, also exterior, but they're lighter type of anchors. Here are again two-piece connections where we create slots to give adjustment for the installer in case the structure's out. It gives a little more adjustability. So a big thing is testing, and we often get historical testing, and again, depending, you see some of the nature of the projects we're dealing with, we want to really know the material properties that we're dealing with. You know, various stone materials, various coefficient of variations, various environments that we're dealing with. So I want to give you an example of here why this is really important. I've got here two examples of materials that may be given to us that are 1,000 psi strength. So the flexural strength's 1,018, and this one's 1,006. In essence, they're the same strength. If we get, which very often all you get is, well, flexural strength's 1,000 psi. Great, we can work with that. When we track all the various test results to give us that average, we can see that this has a coefficient of variation of 7. You know, I'm getting a little technical here, and this has a variation of 29. I'm going to demonstrate here what that means. When we chart all the test results, the blue one is material A, so we can see the varying test results kind of tracking along a very similar line with an average of 1,018. We have material B, which I've got test results failing down at 500 or 600 and as high as 1,400. But when I get my average, it's 1,000 as well. The variation in these two materials requires me to design them very, very differently, although their flexural strengths are very similar. The consistent material I can comfortably design to a lower safety factor, a safety factor of 3 in granite, maybe 4 or 5 in limestone. Whereas if I'm dealing with this variable material, which sometimes may be a result of veining in it, maybe a result of different inclusions in the material that could result in those variations, we need to design to higher safety factors in order to design for that variability. So this is why, from an engineering perspective and a project's perspective, understanding the material at this level is extremely important. So we really push for this, and it's not a big cost item to get flexural strength testing done like this. You're talking about maybe $3,000 to $5,000 on a project. So when we're looking at a cladding job, it's a very, very small price to pay to really understand the material we're dealing with, and very often avoid over design. If we know we have a very consistent material, we can design much lighter conditions, we can span further, we can give the architects bigger panels. So there's a lot of benefits in getting this information very early. Large, high-profile jobs, again, when we look at testing and mock-ups, the job on the left is the project we're working on with Brett right now. So in order to really test that whole system that we were providing, they did air, infiltration, water penetration testing. So they created a chamber. Brett and his crew, and actually specifications actually specify that the crew that's installing on the job site needs to install the mock-up, because they want to really reflect the job conditions as much as possible when they're doing these. So his installation crew that he was planning on using on the project went and installed the mock-up, sealed it all. They created an airtight chamber, and they actually created a negative pressure in the chamber, and then drove it with water and measured if there were any breaches in the system at all that allowed water or air to go through. They also did smoke tests to see if air was going in. And we did actually find, not with our system, but the curtain wall supplier on the skylights, right along the integration between the stone cladding and the way the flashing was going in, there was a failure there that resulted in a redesign of their connection there. So these mock-ups can be very, very effective. Again, you know, on a small project, you're not going to do a mock-up of this scale, but on larger, high-profile projects, you know, trying to create mock-ups that really reflect a lot of the complex interaction of building materials is very critical. The one on the right here is actually a courthouse building that we worked on in Seattle, and because of the seismic requirements and the building design, we had to design this second floor to sway as much as 3 inches from the ground floor. So our connections had to be able to take a story drift of 3 inches. So when this testing mock-up was built, they shifted this second floor 3 inches to see if it could take that much horizontal movement. So you can see here, this is during testing, you can see the shadow line right at the corner where it's starting to shift out. So all the connections on the corners had hinge connections that could allow the panels to rotate without applying pressure on the adjacent panels. So these corner panels rotated around a pivot point there. We actually tested them to 3 inches, brought them back to their state, tested again, and everything, there were no failures of the stone. And then they took it to 4.5 inches just to see how much the system could take. There were some cracked panels that developed, but nothing fell off the building. So very encouraging and comforting that you know, our design approach was appropriate and effective. Other things to consider. I mean, we talked a lot about this during the course. I mean, engaging the right stakeholders, depending on the size and nature of the project, really, really important. Bringing a cladding person involved very early. Engaging the stone detailer, the quarrier, the installer fabricator. And again, we're doing more and more of this now because it's really proving to be the best and most effective way of approaching projects, because everybody can really have an influence early on with structure, architect, you know, general contractor or construction manager, and really all the stakeholders become part of the process. Brett was the president of the Natural Stone Institute a few years ago. I'm the current vice president. It's an international organization. You know, Euromarble's a member. And we are driving excellence in the industry, and they do have an accreditation program that pre-qualifies installers and fabricators. It's a very thorough quality assurance program and metrics that measures and monitors the accredited companies in order to maintain a certain level. And they have various categories. So again, it's you know, not a bad idea to check if the, you know, if your installers are qualified, if they meet the requirements. You know, do they meet the quality standards that are set by the industry? And there's, you know, if you go on the website, this is a great resource for natural stone. A lot of education on there. You can look at which companies are accredited through the organization. So I just thought I'd share this as a great resource. So if you want to take that down and check their website, There's a lot of CEU accredited learning units in there that you can take online. Some of them are offered live, but there are a lot of them that are pre-recorded and you can take them on your own time. So I thought I'd share that with you. Now I'll run through a couple of other project examples. This is the Canadian Museum of Human Rights in Winnipeg. We were involved again very early with the stone selection process. This is an alabaster that came out of Spain. The original concept of this was large panels spanning the full height of those ramps. When we visited the quarry and saw how the stone was actually quarried, there was no way they would ever be able to supply the job in that quantity at the sizes required. So the architects went back and looked at, how can we do this, and developed 3 different panel widths and 3 different panel heights, and created this random mix of panels in order to utilize all the materials. Several mock-ups were done to check the backlighting, because these were backlit alabaster. We wanted to check and to ensure that the anchors we were designing were not creating shadow lines, feasibility of the anchors. Here is the anchor that we actually designed. So a very small pin connection offset from the framing in order to allow light to diffuse around the anchors. And it actually was a very effective solution. Various lights were tested also. And another big part of the design process with the lighting consultants and maintenance people on the building was, how do we change the lights if a light burns out on these ramps, which is inevitable, even though we're using LEDs with long lifespans. That was also part of the process. There was very complex geometry on some of the corners and how that was all going to work. And here is a plan view of our detail, and there's the actual execution of the actual connection on the corners. So again, the mock-up allowed us to check, does this really work? Will it work on site? Do we need to make any adjustment? And as it turned out, it was quite effective. So again, when we're looking at some of the challenges, geometry was also obviously a challenge. When we look at modeling the full ramps, all the ramps were fully modeled with the structural trusses. So we received the models from structure, or the steel fabricator actually from the structural engineers developed their 3D drawings. We integrated all our material. The architect actually acted as a hub, so we fed all the material to them, all our various models. We did any conflict resolution. Everything was vetted at that point. And if there were any issues, we were able to identify them very early in the process and work through them. Here's the challenge that we came up with on light replacement. Every coping and every panel on the top was designed as a removable connection. So we drilled these little holes, designed a socket head cap screw with an Allen key that could remove this connection up here. So you can go through here with an Allen key, undo the connection, lift this up, and rotate the panel out for light replacement. Again, also part of the being involved with the whole process, we actually used our stone connections to anchor the railing as well. So we integrated all the spacing of these with our stone jointing, because it did vary, because the panels varied in length. So we worked closely with the miscellaneous metal contractors on their connections and coordinated all the anchors back through our stone. We created little recesses here in the stone joints to allow that to go through. So a lot, very, very complex, but the job went smoothly because all the critical stakeholders were part of the process. Another great job we worked on. This is the first permanent memorial at the United Nations in New York. Worked with Rodney Leon Architects. We worked with the steel fabricators. We used CATIA as a modeling tool. So you can see here the steel fabricator gave the main structure, which is the blue or the grayish light gray material. All the dark gray is all the supplementary steel that we told the fabricator we're going to need you to supplement in order to facilitate our installation. So we modeled it all up, gave it back to the fabricator. They were able to fabricate all the parts right off our model, and the execution was fantastic. The other critical thing, because of the geometry of this, was the sequence of the installation. This was a project that, you know, for the most part had all blind connection, because this whole structure was going to be encapsulated in stone, and you can actually walk through the middle of it. So what we did for the installers, we created an animation sequence for them that actually, and this is, you know, one by one, we told them which stones have to go in what sequence in order to aid the installation and allow them access to all the connections. So we color coded and gave them the sequence of all the installation right to the end. And you can see some of the nature of the connections. You know, if you don't have access to this, there's no way to install it. So sequence and which stone went first was extremely critical. So that's why we provided that to them. And here we can see the completed project. Not a large structure, but extremely tight schedule and very complex geometry from a fabrication perspective and an installation perspective. And here's after the opening. This was the opening ceremony with the architect at the United Nations, where they unveiled it, and they had all the UN people were there from the head of the UN and on down. So it was a really cool celebration to be part of. The last thing I want to close out on is sustainability, which is a huge part of you know, architects and engineers and climate change, and you know, selecting right building materials for the use of our projects. And as a stone industry, we're working very hard to tell the story, because when we look at the life cycle of the building material from the source to the placement of the building or use on the building, and consider reuse or recycling at the end, this is an independent study, and there have been several done. And depending on who's doing it, you can get the scale moving up and down. But stone is consistently, when we look at total embodied energy, one of the best building materials to use. And this is just a chart. And when we can explain kind of why that's the way it is, I mean, when we look at energy consumption in the whole stone process compared to, you know, other materials, other building materials that have heavy manufacturing, heat, molten, you know, high heat, you know, steel fabrication, aluminum fabrication, glass, and the amount of energy that goes into the fabrication compared to the stone process, really the biggest energy consumption is transportation, because the amount of energy required to drive a wire saw or a diamond blade is really quite minimal when you compare to heavy manufacturing and a lot of other industries. Transportation from quarry to processor, very often this is at the same location or very close. Transportation to fabrication can be, you know, very often overseas or some to another location, and then it needs to get to the job site depending on where it is. But any other building material also has the transportation too. So when you compare the actual energy required to fabricate and get the material onto the job site, the amount of energy is really quite low. And then we all know, I mean, stone can be repurposed, recycled, reused. Very often historical buildings are, you know, dismantled and reassembled. So I mean, a good stone can last forever. So that's in conclusion to the webinar today. I hope, I mean, I've covered a lot. I hope I didn't go too fast, but I'll open it up to questions or comments. And maybe just before we get into it, I'd like to bring maybe Brett and Roberto in. Roberto, maybe if we start at the quarry, some of the benefits, I mean, you've worked with architects all your life. Maybe you can speak to some of the benefits of, you know, visiting a quarry, understanding the materials you're dealing with. You know, how do the materials vary in your quarry, and what are some of those benefits?
Now, starting from the thing that doesn't exist any good marble or bad marble, but only wrongly used marble or properly used project or not. You can make beautiful things with cheap material or vice versa. It's just a question how you study the application, and this is very important if it's done from the beginning. Visiting the quarry is extremely important because it gives you the chance to understand the peculiarity of the marble. Marble, being a natural product, or as well as stone or granite, can have color variation or veining. This veining and this color variation can be most probably the best part of it, because if you handle them in the right way, you can get some effect that is unique. Nowadays, we have also the technology, as Mike explained before, to do this virtual dry lay that is removing the subjectivity on the judgment of a piece, because somebody may like the thick vein, somebody may like the small vein, or somebody like no vein. But three of us can be the right person, because the right decision to use it. It's a question to handle in the right way, how you put it down. So the quarry is the first step always. Then a visual mock-up done with the slabs, not with the samples, is the second step. And then nowadays with the virtual dry lay, it's even possible to show the final product before cutting one piece. And this means less wastage, means no material to throw away. That is very important.
Brett, maybe if you could chime in a little bit on the, you know, some of the benefits of somebody like yourself being part of the process early, and how you can influence and engage in a project, and the benefits for you later. Maybe some of the issues that you've dealt with where, you know, you're kind of stuck with what's there on the building.
Yeah, thanks, Mike. Probably one of the biggest single challenges in exterior, even interior wall cladding, but more so in the exterior, is budget competition between inferior substrates such as metal stud, less with masonry, versus a full wall system approach where the contractor, the engineer such as Picco, would get involved, and we would design the entire structure that supports the stone, that also includes the air-water vapor barrier. And I find that when we do full wall systems where we provide the backup system in a variety of different methods, so many tolerances are overcome, so many enhancements to the quality are achieved. It's just a far superior thing. And I think architects are on board with this once they get educated about the benefits to it and the single source of responsibility. You can enlist design assist at a very early age, very early stage, to get all the bugs worked out in that respect. That's an area that has really got a great potential for collaboration between architects and what I call engineers and builders. The current state on a lot of handset stonework on the outside is the exterior wall systems have tolerances that don't accommodate our tolerances. And in fact, stone is always required to be perfect, not only visually, aesthetically, but from an installation standpoint and from a performance standpoint. And many times when we have to attach to systems that are not integrated in our design, it's kind of a big compromise. So I would always welcome inquiries on how to do a full wall system. It can be done effectively and efficiently. Aluminum generally tends to be the material of choice because it's easily thermally broken, and we can create rain screens. We can do a lot of different contemporary ways of building the wall section to give energy savings to the building as well. And of course, today there's a tremendous amount of pressure on the vapor and the air and the thermal and water. And our full wall systems really encompass that as an entire system. And I find that when the system is designed full wall, there's just a much better warranty, much better long-term performance.
Thank you. Roberto, on the when you're dropping those blocks off the mountain there, do they often crack or do they break, or are you kind of vetting the where you're cutting before that?
Now the bench have what we call a bed that is done with rocks. So when the stone, of course, it depends from the height of the bench as well, depends from the quarry. Where is broken the bench is always where you have a natural crack that will have to open anyhow. So is a first selection that has been already done. Nowadays, with looking the crack, we can make some study, so we can have some kind of also with the experience of the quarrier, we can know how long is inside, how deep it is, and if we break or not before it's falling down. So we will try when we cut the bench to be already aware, and sometimes we use the natural cut to save some cut with the diamond. So we follow the natural crack when we put down the bench. So we are sure we use it by purpose. That actually is what the Roman used to do. It's a very antique system to follow the crack to core a quarry. So we don't use explosive anymore, because explosive can break also the good materials. So we try to follow the natural crack that are already there.
So I saw a comment here coming in that a question, maybe Brett or Roberto, you can speak to this, is could you elaborate on the use of honeycomb product, why it would not be used more frequently than just in soffit situations?
The honeycomb is something that we're using more and more. Of course, where you need the light weight. So it's 100% on the cruising vessel or the cruising boat are done with marble with honeycomb. Elevator cars are always done with that. When you touch an expensive marble, makes sense to use honeycomb, because you can be cheaper with a 5mm marble on honeycomb than a 3/4 of inch statuario, for instance. So in this kind of case, it's possible to do it, and the final effect is also good from an economic point of view. When you go to some economical material, the cost of the honeycomb is so high that it doesn't give you the chance to do it, because it will be much more expensive than the 3/4. So a lot depends from the type of material that we use.
Mm-hmm. Mm-hmm. Good. I saw another question here asked to elaborate on the post-tension stair. So this is something we, like I mentioned, we are working on a couple of other projects presently with post-tensioning. Relatively new to the stone industry. I mean, there are some other ones out there that are done, but it is relatively new. But the technology is not new. I mean, post-tensioning in structures has been around for a long time. So we are starting to explore that more, and primarily, particularly in high-end homes where, the homeowners are looking for something a little unique. It's really being explored a lot, because I mean, you can do, architecturally, you can do pretty much whatever you want. As long as we have enough beef and overlap on the stairs, we can create the geometry we need to run the post-tensioning through. And anywhere from 2 to 3 or 4 post-tension cables get run through it. So basically, you set all the stones in place, run cables through them. They need to be temporarily supported during the installation. They need to be nested and grouted in order to create bearing between each of them. And then once they're in place, you're basically compressing them and creating a beam. You're no different than a precast stair or a poured concrete stair. We're just creating a structural beam that's going to sit top and bottom. And that's, in essence, simplified version of really what we're doing. Any other? I think there may have been another question.
There's 2 more questions coming in.
I think there was a question from Hassan, Ilana.
Yes. So the question is, for the freestanding stone column supporting steel canopy, why was the top of the column not laterally stayed by the diaphragm of the canopy instead of having a sliding joint?
Sorry, so our methodology there is the columns are designed to take vertical loads. The structure comes out from the main structure and it's designed basically anchored back in, sitting on the columns. So we didn't want the columns. I mean, we could have designed moment connection on them, but we didn't want to design the columns to have to take tension loads by potentially trying to tip over. So we wanted to build that all into the structure, back to the main structure, and really take vertical loads on the stone. The only thing that we wanted to create a separation was thermal movements between the steel and the stone in order to allow for some movement without breaching the integrity of the stone or creating crack joints or whatever. So that's the philosophy behind that. If it's a solid stone structure, all bearing on stone with monolithic stone, it might be different, but which would be more of historic solid masonry type installation. But in this case, it's, you know, basically, I mean, we see so many jobs where you've got stone columns and you got two half donuts and you got a vertical joint in it. It just kind of takes away the whole real look of these solid stone columns when you got a joint on each side. We have done other ones where we've had steel columns through and they create a donut and drop them down. But it just creates a complexity, and you know, we're of the opinion, why not use the stone if the stone's capable of taking the load to eliminate all that? You're paying for the stone anyway. When we create a solid stone and then they got to cut a donut in the middle, you're paying for all that stone anyway.
Thank you. One more question. Is the Carrera quarry still operating? I heard it was closed.
Are you crazy?
That's a good answer.
No, we're operating full time. No.
Plus, there
Actually,
are
we
several
started to work there. Sorry?
But Roberto, there are several quarries. I mean, how many kilometers away do the quarries cover in the Carrera area?
Now, Carrera area is like an horseshoe shape. What is the marble? Geologically, the marble was bored, and we have a 36 quarry operating in Carrera area. Plus, we have all the quarry on the back side of the mountain, the Carpagnana. You get the Bardiglio, some type of Bardiglio. You have altogether we're around 80-90 quarry open. You know, in the past there used to be more because the quarry used to be smaller. Now what we are trying to do is to put together 3 or 4 neighbor quarry to make it one, in order to work it properly, in a better way, also from a green point of view, without also leaving risk for the fabrication. Sometimes you had one quarry that was too deep, the other one was too high, so you had the risk for people that was working on the quarry behind. So we are trying to go down on the same level to make the thing more logical. A lot of changement has been done on the quarry now, and they're much more safe than in the past.
Thank you. Another question for you, Roberto. What is the largest stone panel shipped from your quarries?
Hey, we made a block for sculpture that was 12 meter high, 120 tons, and was done for a sculpture, the obelisk that is here in Carrara, downtown. So the special stone can be made it's not a problem of soundness. The problem is the size of the gangs that normally is 3 meter 20. So let's say 12 foot, 12 foot long. It's the size of the slab that you normally can obtain. If you need some special dimension, should be cut with a wire. So it's a little more complicated, but can be achieved in special size if you wish, for some special need.
Thank you. And another question, I heard that a lot of the material from Carrera is used in the cosmetic industry.
No, not actually. Carrera white is a 99% calcium carbonate. So to be calcium carbonate is used for a lot of things. It's used to clean to make the glass shining, as a filler to fix ink in newspaper, toothpaste, medicine. But of course, it's only the wastage. I mean, when we have the little rocks that are rejected for crack or during the fabrication, these are reduced in 0.3 micron, and they produce a milk that is used in the pharmaceutical industry, but is a small part of the. Not anybody work at Quarry just to do that. We work at Quarry to produce blocks.
Thank you.
Welcome.
And Jeff, I think you had a question. I'm not sure what your question is, so if you want to restate it.
While Jeff is restating his question, Roberto, do you want to just, for the benefit of everybody that's on, talk about quarries above the mountain and quarries under the mountain?
Yes. Normally, the marble has an inclination of 33 degrees in general from the sea up. So what on the marble have lay, so you have different color or different structure as well. So sometimes when you make a quarry in a gallery inside the mountain is to follow the good vein without touching the exterior part of the mountain. This can be for an aesthetic point of view, because you don't touch the mountain. From outside, you don't see nothing. So you are not eating the mountain as look in many other cases if you were from the top. But generally, the technical system is to leave columns after so many meter, so many linear feet of distance, that the column are keeping up the roof. So then you can go inside for miles if you want. And aesthetically, you don't touch the mountain. So this is one of the possibilities. Second thing, a lot of time doesn't give you the chance to follow only the good marble that you find without destroying some part of material that have no use for project, because maybe the marble is too bad or the structure is not good. So preserve a lot of the structure of the mountain when you go inside gallery.
Thank you.
Welcome.
And one last question for Mike and Brett. How much Canadian stone do you typically work with?
I mean, we work with a fair bit of stone out of Quebec primarily. Most of our stones are granites for the most part. There's a few large players there. Polycore's there in Quebec, Lacroix in Quebec. They have, various quarries with different colors, from reds to greens to blacks to blues. Brett, maybe you've worked with a lot of the Canadian quarries, probably Lacroix a fair bit.
Oh yeah, no, I started working in Quebec probably the early 1980s, and we used to import a lot of granite to the United States from Quebec. It's typically in darker colors, a lot of blacks, a lot of dark greens. But granite has fallen out of favor a little bit, but the Canadians are very ingenious, and they import a lot of raw material from the United States, then fabricate it and ship back to the United States. And we also currently are working with a limestone quarry in the Ontario area, actually a renovation for the National Law Enforcement Memorial in Washington. And that's a material called Adair limestone that comes from Ontario. So, I mean, geologically, Quebec is very rich in materials. It's just a question of what's in vogue with design, really. What is desired for color and appearance.
Thank you. So I think that's it for the questions on the comments panel.
I've got one last question. I think something just came up, but Mike, thank you for the presentation. That was excellent. I think certainly from my perspective, I've been to the quarries a couple of times, and Roberto, it was a great trip. The wine was good, the food was excellent, and I think everybody that's on the line should make the trip to Italy at least once. But Mike, to go back to, to pick up on, the three of you, you talked about design assist, and I think it's a great way to go because, the projects that I've been involved with, the key things that we always get into trouble with is you never get what you think you're going to get. The detailing is always difficult. From a structural point of view, I think at one point in time, certainly when I started my career, there were people in the offices that actually knew how to detail connections and do all of that kind of work, but we've kind of lost all of those people in offices. They don't exist anymore. I think partially because we don't do the kind of stone buildings that we used to do in the 60s and the 70s anymore. When you talk about design assist, at what point in the project, and I'm talking about large complex projects, not small projects, do you bring everybody in? I mean, the quarry is an important part of this because, as Roberto said, without seeing the material, you don't know what to expect. You don't know how big the piece is. You don't know what the veins are like. You don't really know what you're going to be working with. But how do you do that when you're in concept design, when you're actually starting? I can see that happening later in the project. I can see it happening in a design build project. But what's the ideal situation? I mean, there's the quarry, there's fabricator, which is a huge part of this, and then there's what you do in the engineering part of it as well. What's the optimum way to actually go about a project? And obviously the three of you are working on projects right now. How do we as architects involve the three of you, and at what point in a project would we do that?
I mean, my perspective is the earlier the better. I mean, no different than bringing in many of your other prime sub-consultants, your lighting consultants, your sound consultants, all those people that become part of that design team. I mean, we're just as important as that. And I think that it's starting to become a lot more acceptable where we are part of that initial design team. I mean, once you've got your concepts and you've got your vision of what that project needs to look like or what your end result wants to be, that's when we get engaged because that's our goal. We want to make that happen. What do we need to do? Like Roberto said, there's no bad stones. It's just you got to use the right one for the right application. Which is the right stone for you? Which is the right stone that's going to give you the result you need? That may require, at the beginning, if that stone is extremely important, well, it's not going to work at 3 cm, but it will work at 5. Okay, if it's early enough in the process, what do the structural engineers need to do now to ensure that we can support 5 cm stone instead of 3 cm? Or what else may we be able to influence on that structure in order to give you what you want? So I think that the most successful projects that we work on are very often the most complex. Because of the complexity, they bring us in early because they don't know how to do it. Whereas, more conventional buildings have the similar challenges, but because it's just a cladding, it says, well, they're just flat panels, the installer will figure it out later. I mean, we worked on the South Financial Core here down in Toronto, and we had all these stone panels coming down below the slab level. There was no miscellaneous metal there. It was just they were coming down below the structure about 7-8 feet, and nobody had accounted for the structure there to pick up the stone. Well, it was a huge extra downstream in the project when, well, what are we going to do to support the stone here now? So we got called in, designed a bunch of framing and whatever. So those are some of the things that, we just eliminate all the surprises. Brett gets involved with a lot of the logistics with the GCs. How is he going to access the area that he needs to get to? Who needs to go there? Can we share the cost? Can we build one stage that serves me, the guy doing the soffits, everybody? I mean, all that collaboration is extremely important. And the earlier you get in, you know, working with the Ellis Dons or PCL or whoever the construction manager is, and really vetting a lot of that with them, you know, a lot of the job site requirements. And you know, Brett gets involved with a lot of that very early on, and really helps facilitate a lot of the other trades in how he's collaborating and dealing with. I mean, he's got to get on the whole facade. There's a whole bunch of other guys that need to get there too. So, I mean, I kind of a long answer, but the earlier the better.
Yeah. Yeah, as I said earlier, I definitely see it on, you know, design build where, you know, where you've got an Ellis Don and you've got a PCL, and they're, you know, those issues are important to them because it's, you know, it's the miscellaneous metals, it's the attachments, it's the connections that they need to know because they've got to price them, they've got to hold that price.
Sylvia, I think it's philosophical too. Remember something about this group of people. We're architectural advocates, and so who's the biggest killer of architecture? CMs in the pre-con budgetary phase. Oh, you can't afford that. You can't do this. You can't have that. You can't do this. And by having us there to do budgeting, to do detailing, to allow your architecture to breathe and thrive, we serve as a protection mechanism as well to you guys to allow you to make the best building that you can. And I know that's kind of a coarse statement, but it's a reality. I've seen so many great designs and so many great wall systems get thrown away because of uninformed budgetary information and systems information that could have been challenged had we been involved as an intact team. So I think we play a place in helping architecture grow and thrive and meet its fullest goals, along with all the other technical attributes. But having somebody involved very early to design panel size based upon the color, as we talked about, the right stone, the right backup system, all of those things. Once you know the code, you have a rendering of the building, and you've got a basic modulation, that's probably about the time you should start some consulting. And it can be gratis initially. If it gets into a lot of detail, that's a little different subject, you know?
Yeah. So I totally couldn't agree with you more. And I think a lot of this comes with experience, and it comes with age and, you know, making some mistakes through your life. But it's but it is important to get the right information. And as Mike, you know, this whole presentation was getting it right from the start, as opposed to, you know, making mistakes. And to my point that I made earlier, none of us want to be in that position where, you know, we get it wrong, and then there's pieces of marble falling from the building, as we all know. None of us want to be in that position.
Silvio, up to a certain point, I think that people have to understand that to learn marble, you need a life. I mean, when you met somebody who tell you that he knows everything about marble, is a liar, because things are changing. I mean, the quarry today is something, and they may change in 2-3 years' time. So we are dealing a lot of kind of marble from different quarries, because today you need a building in beige, and then need Botticino. Tomorrow you want statuary white. After tomorrow you want taxos from Greece. So it's an updating information that we need ourselves to assist you. And you need a life to learn everything. It's really very, very complicated. It takes time. That's why a lot of time the architect, to avoid to make mistake, they don't use marble, because they are not confident in what they buy. But it's a little like, you need a lot of confidence on your supplier or your consultant. It's like when you go to buy jewelry for your wife. I have no idea if they gave me a diamond or they gave me a piece of glass. This is basically the same things. People can give you first choice, second choice, third choice marble. And a lot of the time you don't realize. Yeah. Or you realize when it's too late. So that's it.
True. Very true. Ilana, are we good?
There's 2 questions. I guess the first one is for you, Brett, just to elaborate a little bit on granite falling out of favor comment that you had earlier.
Oh, well, this isn't news. I mean, most of North America and Western Europe features the glass box. So we've lost a lot of cladding market share. And I often say we've just become decoration at the base of the building. and the horizontal or elegant lobbies. You know, it's really architectural trends. I mean, we've lost market share for cladding to either architectural terracotta, architectural precast, glass, a variety of products. It would be wonderful to see more and more cladding used in natural stone with contemporary systems. And I think that's one of the reasons I'm willing to volunteer my time for webinars like this, is to encourage people that there are resources and networks of people out there that are very ethical and willing to promote and educate in a very fair, forthright manner to give you good products. So it really starts with what the architect's visions are for the building along with the owner.
Thank you. And last question for Mike. If you could talk about what went to in terms of structural, supporting all that stone for the steps to be self-supported with the 3 cables. Is that the most sustainable approach, considering more similar technology stairs are in the pipeline?
Okay, so the first part of the question, I mean, the support for the stair is a temporary. I mean, 2 LVLs with some, you know, basically build a wood stair underneath it, build the stairs such that we could shim it and support the stones up there, a chain block with a rail to bring the stones down and set them all in place. Once they were set all in place, shims were knocked out, the temporary support was brought down. So really very simple. And to be honest with you, me and my son and one of the guys at the office here actually went and built the temporary stair on a Saturday morning. I mean, I still like working with tools, and I said this is a good thing for us to do, so we actually built that ourselves. The part here, is that the most sustainable approach, considering more similar tech stairs are in the pipeline? I'm not sure what you're referring to there as far as tech stairs. I mean, from a sustainability perspective, I mean, there's no steel, there's no structure other than 3 cables going through it, and post tension with 2 steel blocks on the ends. Again, I'm not sure what other types of stairs you're referring to as far as in the pipeline, and these do have limitations. I mean, there's places where they're going to work, and there's other places where they might not work. But in the right application, I mean, I've seen some of the finished stairs. They're quite impressive.
Thank you. There's no other questions. Lots of comments thanking you for the presentation. It was very enjoyable and informative. So, thank you.
Well, thank you all, and again, I hope you appreciate it. I want to again just really thank Roberto and Brett for being part of this. You know, we've had the pleasure of working on some fantastic projects over the years and cross paths all the time. So whenever we get an opportunity, we love working together, because as Roberto said, we've been in the industry pretty much all our life. It's our passion. We love it. We love challenges, and we love making things work for, you know, architects and designers like yourselves. It's a real pleasure.
Mike, on behalf of NORR, thank you very much for doing this at our NORR Ed. It was an incredibly informative session, and as Roberto said, we need to keep learning. Part of the session of NORR is to continue to learn. That's why it's our continuing education session. Roberto, thank you for taking the time. Hopefully, when this whole thing is over, we'll make a trip and we'll have a glass of wine together. Really thank you for being part of this, and especially with the late time. Brett, thank you. I think, you know, we actually had somebody else that was going to join us. You filled in at the very last minute, and we certainly appreciate that. But you know, the threesome that were on the line are all part of this whole subject matter, and I think that certainly what you do brings a lot to this session, and certainly, you know, I can't overstate the fact that you know, natural stone is one of those materials that's important in our business. I mean, I don't think that there's one building in our office that we don't touch that doesn't have natural stone. And we always worry about, you know, how to pick it, how to select it, how to detail it, and to make sure that, you know, we've done it right. And I think that this whole session has really opened our eyes to what's happening in the industry today and what's going to happen in the industry in the future. So thank you to all three of you for enlightening us today. Thanks again.
Well, thank you.
Pleasure.
Continue
Thank
to
you.
use stone, and feel free to reach out to us when you have those questions. Thank you.
Thanks again. And thank
You
you
have an
to
open
all.
invitation to Carrara. Everybody want to come. You
Grazie.
will be my guest.
And grazie.
Thank you
Okay,
very
so-
much. Great presentation.
Okay,
Thank
so
you.
we'll see everybody a month from now with the next one, the Renzo Piano movie. Take care, all.
Bye-bye.
Bye-bye.